Bismillah Rahman Rahim. Beta, the last time now we were discussing law of conservation of momentum. What does that mean? The momentum stays the constant. How did we check? How can we check a quantity remains constant? If we try to change it and then it again remains to be the okay. So when we had to check that momentum stays constant or not, then we tried to change the momentum of two objects. How the momentum can be changed? Force is called the rate of change of momentum. It means force can change the momentum. So to have a force, we need at least two objects, and these objects to in uh, for applying force on each other, they need to collide with each other. So today we are going to discuss collision, right? Now we are having two type of collisions. One is inelastic collision. Inelastic collision. What do you mean by inelastic collision? Which is not elastic. Beta, what is the definition of inelastic collision? It is the collision in which only momentum is conserved. Conserved means remains constant. Such a collision in which only momentum is conserved is called inelastic collision. Means law of conservation of momentum is applied. What is the formula of law of conservation of momentum? M1 U1 plus M2 U2 is equal to M1 V1 plus M2 V2. And previously we had done almost six questions of this, right? Clear? Okay, beta. Now, so what is the summary of this? Whenever there will be an elastic collision, we will only use the conservation of momentum formula, but is m1 u1 plus m2 v2 m2 u2 is equal to m1 v1 plus m2 v2. So straight away, whenever there is inelastic collision, we use this form. But the other type of collision is elastic collision. First of all, what do you mean? What is the definition of elastic collision? It is such a collision in which both momentum and kinetic energy are conserved. Such a collision in which both momentum and kinetic energy are conserved. किसान लिख लिया आपने बेटा?
जी सर।
Okay. Beta, this is in real life is not possible because whenever two objects collide, some part of their kinetic energy is converted into sound and heat. So this is a perfect type of collision which can be ideal means it can only be in ideas. In real life, it's not perfectly possible. Then why we are studying this? क्यों पढ़ रहे हैं भाई हम इससे? Why we are studying this? Because whenever we are doing any inventions, making, sometimes we take the situations to be ideal, perfect time, right? That is why now, whenever a vehicle is prepared by a company, manufactured by a company, they do collision tests and many a test before launching it into the market. Similarly, before uh, launching a missile, every country first tries to test that missile is working properly or not, right? So when we are going through an invention process, we take all the conditions to be perfect. Although the collisions of gas particles now they are elastic. And in A2, we will be having a chapter fully focused on gas, that is ideal gas. And there, that point will come again. The collision between gas particles are almost perfectly elastic. Right, beta? Two. How do you define elastic collision? Such a collision in which both momentum and kinetic energy are conserved. And whenever we will be having elastic collision, we will use these two formulas. What are these two formulas? The one is same, conservation of momentum. M1 U1 plus M2 U2 is equal to M1 V1 plus M2 V. But the other formula is a very cute one. U1 minus U2 is equal to V2 minus V1. We have discussed it. Can anybody share? Rosh and Hassan? U1 minus U2, relative speed of approach. And this is relative speed of separation. They are equal to each other. So, beta, now let it summarize. Hassan, are you there?
Yes,
Whenever there
sir.
is an elastic linear, we will use these two formulas. What are these? U1 minus U2 is equal to V2 minus V1, and the other is conservation of momentum. And I suggest whenever there will be elastic range, prefer using this formula first because it is simpler and this will save a lot of time and working if you keep this in mind. What is that? For elastic collision, we use these two formulas and we have to prefer this one, which is inside the book. Relative speed of approach is equal to relative speed of. Now, how this formula has come? How do we know they are equal? This is the most important derivation we have done so far. We are going to do actually so far in this chapter. So, coming back to this point, Hassan, are you ready?
Yes, sir.
Okay,
Ready.
we are going to do this derivation. And what is that? Beta, that let's say we are having two objects, M1 and M2, moving with speed U1 and U2 initially. They collide, and after colliding, their speeds are changed into V1 and V2, right? So when we say the inelastic collision in for an elastic collision, the momentum is conserved. Which formula is used? M1 U1 plus M2 U2 is equal to M1 V1 plus M2 V2. Right, Hassan? When we say momentum is conserved. So for the conservation of momentum, we are using this form, right? So beta, what do? We rearrange this formula. Wow, how we rearrange? We now bring the values of M1 on one side and M2 on. So this M1 V1 was not having any sign. It was positive. When it comes to the other side, it is negative. Similarly, M2 U2, the values of M2 when going on other side will turn negative. Now, can we take M1 common from these two? You have to write it, please. M1 bracket U1 minus V1. Similarly, we can take M2 common from these two and it can be rearranged like that. Beta, actually, we have only rearranged the formula of conservation of momentum into this form. It's nothing very extraordinary. We have just arranged M1 on one side and values of M2 on other side. We name this to be an equation as an equation number one. Right, Hassan?
Yes, sir.
Okay. जी बेटा. Done. Is it written? Hassan, चलें आगे बेटा.
Yes, sir.
Rosh, is it done? Beta, you can have a look at the screen. Later on, you can practice it at your home. ये आपने याद भी करनी है घर पे जाके फिर दोबारा जुबानी भी लिखनी है डेरिवेशन कॉन्सेप्ट के लिए बहुत इंपॉर्टेंट है राइट You have to learn it by heart, first understand, and then. So, should we move on? Okay. So, coming back to the definition of, as we define beta, elastic lion have momentum is conserved. Also, the kinetic energy is also conserved. Now we are looking at the option of kinetic energy. What is the formula for kinetic energy? So when we say that kinetic energy is conserved, so initially the m1 was having a velocity of u1. What will be its kinetic energy? So in place of m we will write m1, and for v we will write its velocity to be u1, right? Which formula we are using? The same. Just for first object, the mass will be m1 and the velocity will be u1. Clear, beta? Right? And then similarly for the second object, it will be m2 and velocity is u2. u2 square. Hassan, is it clear?
Yes, sir.
बस we are just putting the values. फर्स्ट ऑब्जेक्ट के लिए m1 और u1 रख दिया था वेलोसिटी की जगह वेलोसिटी का स्क्वायर. Similarly for the second, and after cooling the velocities are changes from u1 to v1. So u1 will be replaced by v1, and u2 object's velocity change to v2 will be replaced by v2. And when we say kinetic energy is concerned, means the total kinetic energy plus means when we add these two kinetic energy, this is total kinetic energy before collision, and this is total kinetic energy after collision, and both of them are equal, right? Okay. Now, beta, can you take 1 over 2 common from both sides? And 1 over 2 will be cancelled with each other. Now we are left with this. We rearrange like we did in the previous example. We take all the values of m1 on one side. This comes to be negative here, and m2 on other side, and this sign is changed to negative as well, right? And then we take m1 common from these two and m2 common from these two. So this is over expression number 2. I'm waiting for you to write. Hassan, were you able to understand, beta?
Yes, sir.
Okay, done. Ji beta, should we move on? Right? Sure. And let me tell you, this chapter is going to end today, and I'm going to share the practice questions. The next test on Friday will be of kinematics and dynamics, right? Right?
Sir,
Clear?
both chapters.
Yes. आसान पिछला टेस्ट चेक करके दे दिया मैंने.
जी sir.
जी बेटा. Now, beta, what do we have? We have an expression number one, equation number one, and an expression or equation number two. Beta, what do we do? We divide equation number one by equation number two by equation number one. What does that mean? When we divide one equation by another, Hasan, Sarosh, can you see? What do you mean by dividing one equation by another? It means the left side of this equation 2 will be divided by left side of equation 1. The right side of equation 2 will be divided by right side of equation 1. Clear? This is how we mean. Now, m1 will be cancelled by m1. m2 will be cancelled. The important point, here we are having u1 square minus v1 square. Have we seen in math if we are having square of two quantities subtracting a square minus b square, we can factorize or simplify it like a plus b times a minus b. So beta, these two squares subtracting, can we write it like them? Adding ones and subtracting them once. Hassan, do you understand this beta?
Yes, sir.
Like Sanjay, u1 is a, v1 is b. So a square minus b square is a plus b times a minus b. Clear? So Rosh, have a look at here. So beta, now when we write it like this too, this u1 minus v1 will be cancelled by v1. So we will only be left with u1 plus v1. Clear? Similarly, two squares subtracting v2 square minus u2 square can be simplified to be, once we add and then we subtract, then v2 plus u2 is equal to v2 minus, we are again factorizing like the same formula we have used here. Two squares subtracting, we will once add them and then subtract them. Right, Beta ji? Clear, Hassan?
Yes, sir.
So when we see this negative and negative, they are same, they will be cancelled. The negative expression will be cancelled and we will be only left with this on side. Right, Hassan? Now,
Yes,
Suroj,
sir.
what do? We take U's on one side and V's on the other. So what happens? This U2 plus will make it negative on the other side and V2 negative will plus will make negative on the other side. So what is this beta? This is what we have already discussed. This is U1 minus U2 is relative speed of, and this is relative speed of, and isn't it? Hassan, please write it down. When you are done, please tell me. जी बेटा.
Done, sir.
Okay, that's good. Okay. Ji Saroj, should we move on? Okay. So Hassan, so what is the summary of this? Beta, whenever there will be elastic collision, we have to use these two formula and we have to prefer the first one. Ji Saroj, is it fine? Here, beta? Okay. Now, we are very close finishing this chapter. There are 3 points which I would like to discuss with you, and they are special cases. There can be more than these special cases actually. When if we see American or the world FSC system, but we have to focus on our own syllabus. And one is that whenever two objects collide and they stick together, so that collision is always going to be inelastic collision. Whenever two objects collide together and then they keep moving together, they stick to each other. Like, God forbid, a train when hits a small car on the rail, it takes the car along with it. A heavy boy running when hits somebody, a smaller one, for some distance takes long. Like a tsunami when hits a bridge and takes the bridge along with it. Right? Okay. So whenever two objects collide and they stick with each other, that is always going to be inelastic line. Clear? The second, these now points what I'm going to discuss. These are important for questions, right? The second point is very important. Whenever elastic collision occurs between two identical objects, what do you mean by identical object? Where masses are same, objects are same, equal. M1 and M2 are equal. Then beta, their velocities are interchanged. Means the initial velocity of first object will become the final velocity of second object. The initial velocity of second object will become the final velocity of first object. U1 will become equal to V2 and U2 will become equal to V1. This is only for when there is elastic collision and masses are same, identical, exactly equal masses, right? Important. Clear, beta ji? Okay. Now the next beta. Whenever an explosion occurs and an object breaks into two parts, the object was at rest initially. That is important point as well. If an object at rest breaks into, explodes into, blasts into two parts, then one thing, both parts will have equal but opposite momentum. Why? This will come in the exam many a time. Because according to conservation of momentum, initial momentum and final momentum should be the same. So as before exploding, the initial momentum was zero. Before exploding, before there was an explode, there was nothing happening. The object was at rest. So initial momentum was zero. So should be the final momentum. Should also be zero, right? How can that final momentum be zero? It will be possible when both the momentum of the both the pieces will be equal but opposite. The negative sign shows the directions are opposite. So whenever an object breaks into two parts, the momentum of both sides, both parts will be equal but opposite. And there are few cases now which come in the exams many a times. I would like you to know. If we say the object breaks into two equal parts, means the m1 and m2 are equal, then their velocities will be equal as well. To have equal momentum, momentum is mass into velocity now. So when if masses are equal, then momentum can only be same if velocities will be same as well. But negative sign shows velocities will be
Opposite
opposite.
direction.
If one is right, it's your uh, it's your choice. You write negative with v1 or v2. For showing opposite direction, we have to write negative sign with any one of them, right? This is important, Firoz and Hassan. I want you to look. But sometimes, if the pieces are not equal, let's say the M1 mass, the M1 is M and M2 is three times M, then how can you have the equal momentum? How different? By equal times. If one mass of one piece is three times higher, then its speed will be three times lesser than the other. It's opposite. This point is important. Beta, Hassan, whenever we say na, the parts are not equal. Let's say one is three times the other. Then the heavier part will have smaller speed. Will the larger mass will have smaller speed and you will name the smaller speed to be v. But whenever you are supposing two values now, always suppose the smaller value to be x or y. That will make the mathematical working easier. So I'm repeating. What is that? Whenever the masses are unequal, so for the momentum to be same, momentum is mass times velocity. It means the larger mass will have smaller, slower velocity. The larger mass will have slower velocity, and I suggest that you name the slower velocity to be v. So if the mass is three times larger of the heavier mass, heavier part, then the velocity of smaller will be three times of the larger mass. Right, beta? That many times the mass is larger, that many times will be the speed faster of the smaller object. Similarly, let's say if the two pieces are like if M2 is smaller and M1 is 100 times larger, then whose speed will you suppose to be V? Larger mass, right? And if its speed is V, the other one which is 100 times lesser in mass, speed will be 100 times larger. Will you remember? Whose mass will be smaller by any number, by any times? That many times its speed will be faster than other. But both the speed will be, velocity will be opposite to each other. Now its choice is yours. You can write the negative sign with V1 or V2. So value choice is yours. Both will be correct. Clear, beta? Hassan?
Yes, sir. Clear.
Okay. Now, Hassan, the last point of this, beta, we were focusing, previously we were just considering that two objects, they collide with each other, they were going in some direction, and they collide, and after collision, they keep moving in same direction, beta. But does it really happen in daily life, in common life? Usually moving in exactly same direction is very rare. Yes, it is possible. It's not like that it's not possible, but it's very rare. What we usually observe in our daily life is that sometimes the objects go in different directions. So now when they move at angles, we now say we are going to discuss conservation of momentum in two dimensions. So, beta, first of all, we consider a mass m1 moving up with a speed u1 in the towards the right, and there is a mass m2 which is at rest, means u2 is zero. So when they collide like at an angle, so what happens? The m1 goes towards this direction with a velocity v1, and m2 goes, suppose, in this direction with a velocity v2, and the m1 goes with velocity v1 making an angle of theta 1, and m2 goes downward with an angle of, means for m1 we are keeping its velocity to be v1 and angle to be theta 1. For m2 velocity is v2 and angle is also named to be 2 theta 2. Right, beta? Acha, why one object is going there in this direction and other is going in this direction? Ji, Hassan, beta, why not the both objects go like that? Sarosh, why not both objects are going like, or why not the both objects are going like that? It never happens. Why? Uh, Actually, we are discussing the conservation of momentum. It says the initial momentum should be equal to final. If you see the initial momentum, here the M2 is not moving, but the total momentum here will be of only of mass 1 that was moving. Because M2 momentum was 0, that was not moving. So that object was moving in this direction, right? So it means the total initial momentum will be m1 u1 and it will be in this direction. Can you see this arrow? The yellow one. So it means the final momentum should also be in the same direction. Now, when we say an object goes like that, the other object goes like that. So in vector wise, don't we know that the resultant is always in the middle of both? Can you see the resultant is in reality equal to this is the final momentum green one I have drawn for you. This final momentum after collision is equal to the initial momentum. And for final momentum to be in the middle, in the horizontal direction, the one of the component towards must be in this direction, the other must be in this direction. So the resultant should stay in the middle along the horizontal, right, Hassan? So, beta, we will never see both the objects moving in this direction or both the objects. It will always be like that, right? Clear? Now, as we are going to see the momentum in two dimensions, so we convert each object's momentum into its component. Like momentum is a vector quantity. What is momentum? The mass multiplied by velocity. So it's the momentum of the first mass after collision will be now, these two are multiplied now, m1 v1, and momentum of the second object similarly to will be m2 v2. Clear? So m1 v1, we are drawing the components here in this diagram. So m1 v1 is in this diagram direction, m2 v2 is in this direction. So m1 v1 will be having one horizontal component which is adjacent to the angle, that is always m1 v1 cos theta 1, and the vertical component will be original is m1 v1, right? And the horizontal component is original times cos of theta, and vertical component will be original vector times sine of theta. Similarly, beta, for the lower one M2V2, its horizontal component will be original times cos of theta. Here angle is theta 2. The previous one was angle theta 1. And the vertical component is original times sine of theta. So for M2, the angle is theta 2, and for M1, angle is theta 1. So beta, now we have divided the components, the momentum of each into horizontal and vertical component. Momentum of each into horizontal and vertical component. Now, we are going to focus on conservation of momentum in two dimensions. So, what are the two dimensions? Horizontal and vertical. So, we have to apply conservation of momentum in both scenarios. Horizontally, we will see only horizontally. So initial, what was the initial, when we say conservation of momentum? Initial momentum should be equal to final momentum. And when we are looking at horizontally means initial horizontal momentum will be equal to final horizontal momentum. So what was the initial horizontal momentum? M1 U1, we write it as it is. And now what will be the final horizontal momentum? Finally, we are having these two components, m1 v1 cos theta 1 plus m2 v2, and both are in the same direction, so they will be the final total horizontal momentum will be sum of these two, right? This is final horizontal momentum, we add them, and this is initial horizontal momentum, and they are equal to each other, right? Similarly, beta, when we say see the vertically conservation of momentum, so what does that mean? Total initial vertical momentum will be equal to total final vertical. Now, do you see any vertical momentum there initially? Nothing. This was not moving at all, M2 zero momentum, and this was purely horizontal. So the vertical in vertical direction, the initial momentum will be zero, right? And when we see the final, we have two vertical momentum, this and this. And the one is upward, the upward direction we take as positive, the other is, so that is why beta, we write directions are represented by signs. We write for vertical momentum, we write this to be positive, no sign means positive it is, and this as downward as negative. So beta, these are the momentum, conservation momentum in horizontal and vertical. We can rearrange it. This minus m2 v2 sine theta can be positive on other side. Beta, these are the derivation, and that is all for what I wanted to do today. Now you have any question, you can
No,
ask.
sir.
Can you note this down all?